This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers, retirees, students, and other not-so-nefarious characters who have limited space, limited money, and limited time. My name is Neil. Welcome. During this video, we'll start work on fabricating the breadboard function's power distribution strips. When I saw these distribution strips in a catalog, I thought I found exactly what I needed. I noted the hole clearly designed for panel mounting, and they have this kind of standardized tongue and groove arrangement so you can stick as many different solderless strips as you want to in whatever arrangement you want. I need 8 binding posts attached to independent connectors, 2 for each strip. Fine. When I took it out now, I noticed that the backing is not triple-coated paper backing that I saw previously, but it is a double-stick foam-based tape, heretofore known as foam-based double stickum goo. I need to remove the foam-based double-sided stickum goo because I intend to solder wires to the back of the conductors, and if the foam is attached to those conductors, it's going to heat up. It very well might char. So I just note that, okay, I'm going to have to remove the tape. It should be relatively easy. I'll get in there with a hobby knife and just peel it off. No big deal. Yeah, right. So I laid down some printer paper, those old-fashioned pin-fed printers that were around 20 years ago, and I've still got some paper for them. Figured, okay, let's peel off this double-sided tape with a hobby knife. You can't do it just with a knife, so I got some solvents. The first solvent I tried was 99% isopropyl alcohol. Just spray that on, and let's see if I can scrape this off a bit. Okay, it seems to be working. Don't rush it, a little at a time. I figured, hey, I've got it made. It might take a bit, but no problem. Now, the isopropyl alcohol is indeed a solvent for the stickum goo. And that's the advantage, and as I'm beginning to realize, the disadvantage of this method is that the isopropyl alcohol is a solvent for the stickum goo. And it is dissolving the stickum goo. And the stickum goo is getting all over everything. The knife, table, my hands. It's a very unpleasant feeling to be totally stuck with stickum goo. And it reduces the kind of dexterity that one needs in removing this tape. However, pressing on, I'm sure I can get this stuff done. If not today, then maybe tomorrow. Boy, is this going to be a problem washing this stuff off. Now, luckily, I have some aluminum foil underneath this paper, so the work table isn't getting screwed up. But I'm not having fun here. Not at all. Now, I know that it appears to the viewer that this took just a few minutes. Let me assure you, it took a hell of a lot longer, but eventually we have removed the foam-based double-sided stickum goo. Now, flipping this over, I noted that the red print had been removed, indicating that the alcohol was perhaps a solvent for the red print. Okay, let's test this notion out. By George. It works, but for some reason it doesn't work on the blue stuff. Okay, one thing at a time. Let's get rid of the red print. The acetone was able to dissolve very easily the blue print. And so here I have a printless, de-stickified set of solderless breadboard distribution strips. And I just wanted to see how this was going to look, and I need to solder wires to join the strips to their corresponding binding posts. And let me just see what the maximum length is for these things. We'll cut some wires to the maximum length and then trim them down later. This is not particularly fun, but it beats removing foam-based double-sided stickum glue. I don't particularly like this wire stripper. It just doesn't give the right grip. It's too much force needed. I've got an automatic wire stripper around somewhere, but not for wires this small, I don't think. I'm going to have to check this out. Alright. Now the idea here is I'm going to solder these wires to corresponding distribution strip conductors, but first the objective is strip the wire and then tin it. That is, apply a hopefully very light layer of solder to the wire. It'll make soldering it to the distribution strips much easier. This is a Hacko 888 soldering iron, and on the left I've got this third hand deal. Apply some flux to the wire, heat the wire with said soldering iron, and to the opposite side apply some solder. Now we want to make sure we remove any excess solder we got. And this is not particularly fun either, but it beats removing foam-based double-sided stickum glue. Alright. Now I'm applying solder directly to the soldering iron. In some cases, the idea here is to assist in the transfer of heat. One should not rely on transferring solder from soldering iron to solder joint unless you have a great deal of flux on a solder joint. And here I am applying a great deal of flux to the conductors, and I wanted to individually tin these conductors to apply the solder to them before joining wire to conductor. And I'm going to try to not put too much solder on here. That's my problem. If you want to learn soldering, turn this thing off immediately. I always wind up putting too much solder on it, no matter what I do. And as you can see, on these conducting strips, there's too much solder on them. No matter what I do, it'll turn out this way. Now what I'm trying to do is just use the scribing tool to pass between the conductors, make sure there are no solder bridges, and get rid of any burnt areas on the plastic. It's not quite as bad as it looked at the beginning, but still there's too much solder on this. I could use a solder wick to remove some of this solder, but I'm a lazy bleep. What I'm using to clean this thing off is a piece of gauze wet down with acetone and then with a drip of isopropyl. That is called by most people a flux remover, acetone and isopropyl alcohol. My concoction is a lot cheaper. Now is the time to solder the wires to the strips, and I'm using a small hobbyist C-clamp here. I wasn't able to find any of these things listed. This is a very old one. It's very lightweight, initially produced by X-Acto, and no longer available apparently. This thing looks like it might have been titanium. Very light. And the idea of using the C-clamp is to steady the wire, make sure we have a decent solder joint, and in part to serve as a kind of a heat sink. Now with all the flux I've lobbed on this, and with the solder on both the conductor and the wire, the soldering went fairly easily. As long as you don't move the objects around when the solder is cooling, chances are the solder joint is going to be clean. There are two ways to do that. One of them is clamping the wires like this. Another way to do this is to use eutectic solder. Eutectic solder has a very narrow temperature range where it is liquid, so that when it cools it goes almost immediately from liquid to solid and reduces the chances of a cold solder joint. And for some reason it's also more expensive. Okay, and some more flux remover. Now I'm going to bend these wires perpendicular to the distribution strip, and using a C-clamp as a means of avoiding putting too much stress on the wires and on the solder joint. Eventually we're going to put some stress relief into this, but right now there's nothing to prevent excess force being used, and I really do need these things pretty much perpendicular to the strip. And not too bad at all. Took a little longer than I thought it should, by about 2 or 3 hours, but otherwise, not a bad job, despite myself and my soldering technique. Now the last thing I'm going to do is test this. And I want to test to make sure that there are no bridges. And there don't appear to be any. In this video, I started fabrication of the breadboard function's power distribution strips. I removed the foam-based double-sided stickum goo from the back of the distribution strips. I soldered colored hookup wire to the distribution strip conductors corresponding to the binding post colors, and tested for shorts. In the next video, we will continue fabricating the breadboarding power distribution strips. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. It's not all that difficult, and I promise to read it. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, vector graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.